Hello team, welcome to question 6, Grays, Hockey, the sponsors. Okay, this question's a bit of a doozy, 8 marks to begin with. So, human body temperature in degrees may be modelled by a normal distribution with mean and variance. Emily, a medical student, measured the body temperature of a random sample of 20 patients in a hospital. She calculated a 90% confidence interval for the mean body temperature of patients in the hospital to be 35.2 to 41.8. Calculate a 99% confidence interval for mu. We don't have a lot of information here, but it is possible to start working things out. The first thing we can work out is what mu is. Okay, so our sample mean. We've got 35.2 and we've got 41.8, and we know that we're going to add and subtract a value to get the confidence interval, meaning that the midpoint is going to be that sample mean. So by putting that into the calculator, we get 38.5. I'm just going to call that X bar. Right, happy with that. Next job, the 99% confidence interval level. So having a look, we can't quite go on to the 99 confidence interval just yet because we're going to need to know what that variance is going to be, or in fact, the standard deviation. So with it being a 90% confidence interval, that means I'm just going to draw this to the right. We're going to have 5% here, 5% here, and that's going to be 0.05. So we're going to have to use the inverse standardized mean, where we've got this is equal to 0, this one's equal to 1, and we want to go on the left-hand side, and our probability or our area is going to be 0.05. So through plugging that through the calculator, we should be getting a value of 1.645, meaning that we can then work our formula out. So we've got 38.5, which is our mean. It's going to be plus or minus 1.645 lots of the standard deviation over the square root of our sample size, which is 20. And that's going to equal 35.2, or it's going to equal 41.8. So for me, I'm going to add it, and I'm going to go with 41.8 so that my numbers can stay positive. 1.645, lots of this rubbish in the bracket, and we're going to subtract from 41.8 to 38.5, giving us 3.3. We then divide by 1.645, so 3.3 divided by 1.645 gives me 2.006079027, and then we multiply it by root 20, and that gives me 8.97. I'm going to choose to round it there. So that is my value for the standard deviation. Now that I've got that and I've got my mean, I can go back to calculating my 99% value. That's I can't draw that. Sorry, I can't leave that. That's why you don't draw the line in the middle first. Concentrate on getting that as a straight line. There we go. So my 99% confidence interval level means that 0.5% is going to go in there, which is 0.005. That's right, 99%. Therefore, we have to put it into the inverse mean. I'm going to just keep my pen color the same, where that's 1, that's 0. The area to the left is going to be 0.005. And when we put that data in, we're going to get a value of, well, it's going to be negative, but it's 2.5758, which will be positive when we get to this right-hand side. So 38.5, which is our sample mean, plus or minus 2.5758, and then in that bracket is now 8.97, our standard deviation, which we found, and the square root of 20. So we put them in, and our plus value is going to be 43.7, and then our minus value will be 33.3. And that's part A done. I'd love to say we're done, but they've snuck a little bit at the end to make this a 10 marker. Emily claims that the mean body temperature of patients in the hospital is above 37 degrees. Comment on her claim. Well, 37 degrees falls within this 99% confidence interval, and it falls within the 90% confidence interval. Therefore, it could be 37. It might not be above 37 at all. So because 37 lies within, I'm going to put both confidence intervals calculated. Her claim is wrong. There we go. Right, that is question 6 done. That is the end of this paper. Good luck for your exams. Study hard. I hope you get the best of results, and I'll see you next time. Bye-bye.